Welcome to Ask and Learn.
Hello and welcome to this video solution of numeric. Here it's given that the 4 kg slender rod rests on a smooth floor, right? So the mass of the rod is 4 kgs, right? And it rests on a smooth floor. It is kicked so that it receives a horizontal impulse I, which is 8 Newton second at the point A, right? Now you have to determine the angular velocity and the speed of its center of mass. So this is pretty simple. So what you can have is the length of the rod L is 2 meters, and the distance of A from the rod end is 1.75 meters, right? D is 1.75 meters. So here we have the rod and here we have the point A, right? This is D and this is L, right? The angle of impulse is theta equal to 60 degrees, right? With the axis of rod. So this is the impulse F, let's say. This is 60 degrees. Right. So these are the given parameters, right? So what you can do is you have to find the moment of inertia of the rod, right, above the center of mass. So I will be equal to 1 by 12 ml square, right? So you have got 1 by 12. The mass is 4 kgs, 4 times of 2 squared. This is equal to 1.33 kg meter square is the moment of inertia I've got, right? Now let a force F is generated due to impulse I, right? So there will be force generated, right? So what we can do is you can uh, have this expression of impulse I that is given by integral of F dot dl, right? Oh, sorry, dt. Yeah, right. So if you just take the product of force and the time, you will have the impulse, right? Now for that, what you need to have is the you calculate the moment about the center of mass of the rod. So this is F sine theta times the distance, right, which is d minus of L by 2, right? This is from the center of the rod, right? Moment about cm, right? And if you plug in the values, then this is F times of sine of 60 degrees. Here you have got 2 minus 1.75 by 2, right? Sorry, the reverse. This is 1.75 minus 2 by 2, right? And this will come out to be equal to 0.65 f, right? Now what you can have from here is if you just conserve the angular momentum, right? Here what you can do is I r omega 1. So this is a initial angular momentum. Now there will be this application of moment m dt 0 to t, right? This will give you the final angular momentum, right? Moment of inertia will stay the same, omega 2, right? And this is 0.65 is the moment m. I'm just replacing this with force F, integral of F dt. This will be from 0 to t. This will be equal to, if you take the moment of inertia, this will be omega 2 minus omega 1, right? And what is this? This is the impulse, right? Which is 0.65 I is the impulse, that is equal to IR omega 2 minus omega 1, right? This is IR, sorry, this is IR, right? And this I is the impulse. And you will be having, this is 0.65 I is given as 8, this is equal to 1.33 uh, omega 2 minus, sorry, omega 2 minus omega 1 is 0, right? So from here you will be having the final angular speed as 3.9 radians per second, right? The final velocity you can calculate from the expression of impulse I, which is equal to mass times velocity v2, right? Impulse is also equal to change in momentum. So initial velocity is 0, which is v1. This is 0, right? So I is 8, right? This is equal to the mass is 4, right? Times v2, right? So v2 will be 2 meters per second, right? I hope this is clear to you and have a very good rest of the day. Thank you.